Hello, everyone. Give me a thumbs up if you can hear me. This is Taryn Blake speaking. It is the Community Engagement Program Manager for the DISW. So that is our digital industry software community. We are here today for another session of our Technomatics virtual user group and happy to have all of you here. Our topic for today is how to create a two-lane turntable. As you probably know, our speaker is Stefan Vongsau. He is a freelance simulation expert who has been in this space for several decades, doing hundreds of projects and training sessions. He has 5 books already published on plant simulation, is working on a 6th book at this time. And he is very often found in our Siemens PLM community forums. So today's big 3 steps for the project are: 1, to create the turntable based on track and transporter. Stefan will show you how to add lanes and also to create a basic control for that. As always, we are live today, so Stefan will be presenting in real time, and we have a live Q&A. You're able to ask questions verbally by hand raise as well. So if you're not familiar with Teams, the hand raise button should be in the upper middle of the menu items there. So when we get to the Q&A, feel free to press that button. We'll take you off mute so you can ask your question easily. Of course, we do have the live chat as well, but a lot of times hand raise is a little bit easier to get into the details. So that's all I have for our introduction today. Stefan, you're welcome to take the screen.
Hello, everyone, to our today's webinar. We will create a 2-lane turntable, and so we start with a basic scenario. So I want to have here a conveyor. I make it 5 meters and name it L, just as a blueprint. And then I copy it. I have the conveyor going in. Okay, I need to switch on the oh. I need to switch on the names in the class here. It's conveyor, 3D properties, and I need the names. Okay, here segments reverse and another one in the same direction. And I have other conveyors 90 degrees. Oh. Okay, this is our basic scenario. Conveyor, 2 lanes with different directions. One direction is from left to top, and the other is from top again back to left. And here should be a turntable which can provide transport to both of the lanes. And the turntable here in Plant Simulation only have one lane, and you cannot change this in this way. And so we need to create our own turntable. And today I want to show you one approach based on track and transporters. This is, for me, it's the old way, because in 2D, you could make a lot of objects in this way to load a transporter on a transporter and another transporter on a transporter. And this was the default setting, for instance, for the multi-portal crane until version 16. Okay, I need one source to create here parts. I want to create parts with a uniform distributed distance between 2 and 6 minutes. And I start this source after 10 seconds. And I need a source in this way. And again, the source in this direction. Interval. Uniform distributed between 2 and 6 minutes. And this should start from 0. And another train. Okay, next I change my part here. The size of the part should be 5 meters and 1.2 meters width. Okay. I guess you know that the transporter will, if you have a curve on a track, then simulation will turn the icon of the transporter in direction of in driving direction, and this you can use to create rotating elements. First, we need a track, a complete round track, and so we need the track, and then press the keys Control Shift and make a click into the frame. And then it only works in one direction. Then you have the possibility to change the radius here. Radius 2 meters is okay for us now. And then make 4 anchor points. And that's it. This you need maybe to train a little bit. Make it again. Click on the track here in the toolbox, then press the key combination Control Shift and click into the frame. And then you will see you can change the position of the cursor and press again Control Shift, and then you have the direction of the track. It needs to be in this direction. It only works in this direction. And then make 4 clicks. At the end, click right mouse click, and then the track is finished. And you need to connect the end of the track with its own start. So we have a complete round track with a radius of 2 meters. And now we need to create a transporter that is round and is able to turn on this track. So duplicate the transporter in the class library. And this will be our double turntable. Rename it. And open this in a new 3D frame. Okay, this is the transporter, the default graphic, delete all this stuff here. We also don't need the states here. So we have a clean window, and now 3D edit. You have here the shapes, and we need a cylinder with radius of 2 meters, and height should be only 0.1. Great. And this is now very important. The position of this should be in this way. You can edit the 3D properties, and the position needs to be 0 to 0. Not centered here. It needs to be in this way. And we can place some point here, 0.2, create. I place it here to show, okay, it's turning. Okay, that's it for this. So now drag the double turntable here onto the round. Okay. This is not how it should look like, but this is because of the MU size is not right here. You can open the turntable dialog and then tools and calculate dimensions from 3D. And then it should fit on our track here. And if you now start the simulation, then you see, okay, it's rotating. Okay, in this way, you can create your own rotating elements. Later on, we will have a webinar for dial plate operations, where you have here one element with several places, and around robots and machines and so on are fulfilling different operations. In this example, we need on this turning element 2 lanes. And the lanes should be like conveyors. And so we have not so many different objects we can use for this. The only object we can use for this is a transporter with a load bay type of line. And so in the next step, we need to create lanes. So duplicate another transporter, and I name it double turntable BTT element. Open this in 3D. No, first we need to set up here the load bay. load pay type should be line, and the length of this is 4 meters. Okay. Then open this in a 3D frame. And again, first we just delete the old graphic here. We don't need it. And I don't want to have the states. And then create a cuboid, x 4 meters, y 1, and z 0.1. Okay, we need another material here, maybe black. Okay, this is one of our lane now, and we need to change the 3D MU animation. The track itself has several types of animations. The transporter has several types of animations, depend on the loadway you select here. We have the line, so we need to change the line animation. Show it. You see it's in this direction, completely wrong. And so you need to change the animation. This is anchor point 1. From here to here, you can track the anchor points in the right direction. And you can also change the height here by marking the anchor points, then hold down the Alt key, and then you can move the anchor points in Z direction. Okay, I need to close this one. Okay. I want to have a direction arrow here, some to show the direction. So I name a cone frustrum. Sub radius, button radius should be 0.2. Height 0.2. Create. And this I flip around the y-axis by 90 degrees. And so I have some direction. Okay, and this I need for the other direction as the second lane. So I close this and duplicate this element with all the settings and name it backwards. Open it in 3D and just flip it here in the other direction. So this only flips the graphic, and we need to change the MU animation. Animation line show. This is still animation anchor point 1, and this is still anchor point 2. And so this is the wrong direction, and so I need to change the position of these two anchor points, that I have the right direction of the animation on this lane. Okay, you can also edit this position with the 3D attributes of the anchor points. There you can set this easier. Okay. So now I have two lanes as a transporter with the load bay type lane. And now I need to set two animation points on my double turntable here. I need to change first my dimension of the store here. I need to have two X and one Y dimension, only two places I need. And for these two places, I need to set the animation points in the right way in my turntable. And so I need to go back in 3D. I delete this one here. And I need to change the 3D MU animation. I don't want to have an animation area here. I want to set the animation parts manually. I need to set it by the positions here with route 0, route 0. I have the first position, and I need to change the position of this. I make it here directly with the position of the anchor point. The position X should be -1 and Y 2. And this is the right position, and set K 0.1. It's okay. And I need a second one point here, route 1, route 0. And the same play here. I added the position of this. Y2 is okay. X should be 1. Okay, now I have a transporter with two animation points, and I can check this now. Here's my turntable, and now I track my lanes here on the turntable. So, and this is strange in Plan Simulation now. We need to make some settings here that Plan Simulation don't fit this into this area here. One moment. So, okay. First, this elements here. Okay, we need to add the 3D properties. Scale automatically, we need to uncheck. And now the position is not right here. We need to turn this by 90 degrees. And this we make also in the double turntable. MU animation. We can make it here with this here. Edit tree properties and the anchor point. And here you can set a rotation of 90 degrees. It's good. And the same for the second. Mark the anchor point, and then you can change here. You can set the rotation. Oh, this is I don't save the changes here. Okay. I need to change the position a little bit. So these are the building blocks of my double turntable. I have a turntable. I have one turntable element and another turntable element. And it turns. Now I need two steps. First step is I need to create this this double turntable each time the simulation starts, and so I need an init method to create all these elements. And a second step is I need to create a method how to load parts on the right lanes here. And before we start, a little trick to get a better orientation and positioning on the track. I make this turntable very, very small. So I change here the MU size of this turntable to 0.001 meters. And now you see it's again scales this. And so I need also for the turntable switch off in 3D the automatic scaling. And this I make that I have a better control about the position of the turntable. I don't need to calculate where I want to stop. I want to stop on the start here. Okay, now we make some settings here. I make this inside this track here, and change the name. In double turntable track. And develop all the stuff here as user-defined attributes. I need one attribute for lane 1 as object. I want to store a link to the lane 1. And next, lane 2 as object. And I need one init method as method. And this I want to So I start to create the turntable. You can drag it from the class library into the method editor, user object double turntable point create. Self is the method, and point tilt here is the location of the method, and this is the track. Then I create the first lane. And this is my double turntable element. I created on TT and get here a reference for lane 1 and the same for lane 2. And this is element backward point create also on TT. And then I want to drive to P. This is quite easy here. We need to set a destination for this for the transporter. The radius is 2, and the circumference of this track is 2p radius, and so a quarter of this track is p, and so I can use p to drive to set a destination on this track here. And to drive the turntable, I use the attribute target position of the track of the transporter. And P is a constant here in SimTalk around with D. Okay, this creates my 2-lane turntable, and it drives by 90 degrees, and this I can check now just by start the simulation. So I guess my lanes are wrong here. Okay, and so we need to drive to 3 times P. It's live. Okay, we need to check the behavior later. Maybe it's just the wrong rotation of this element here. Okay, I want to have a quite simple control. At the end of this lane and this lane, I add these parts into a FIFO table. So I make a table here. You only need one column, and this column should be object. And I need init method. To delete this FIFO table at the start. And I need a method as exit control or register the job for this turntable. And this should be the exit control of this lane here and this lane. And this should only make an entry into this table. Quite simple. I just add this lane or this conveyor into the FIFO list. And so I have the order of transports. Also, if I have more of this lanes here. And then, of course, I need a method to control this turntable. And so I make another method. Do job. And this I also call the first time in the init method. And so I call it the first time here in the init method, and then it calls it by themselves here. Okay, do job. And now I need to make it a little bit. I need to hurry a little bit. First, we have to wait for a job. I can check item. If this is bigger than 0, then I have job. I read the first entry of this table, and then I delete this first row here. And for better readable code, I want to have an object variable of the turntable. And the turntable, this is my double turntable track point cont. Now I have two cases. One case is this is L2, and this only for checking target position needs to be in the -1 before we start. And then we need to check if we already on the right position. And we cannot check this with equal, because it's maybe some 1 millimeter before or behind, and so we need to check it with near 3 multiplied with p. And if we're not on this position already, then we change, then we drive to this position. Okay, touched position will be set back to -1 by planned simulation if you reach the target. So we need to wait here for finishing the movement. We need to wait for target position is -1. Guess I have. Then I move the part here from station to the right lane. My example, it's lane 2. Okay, I need to change there something. Okay, this is only P here. And then we need to wait, for instance, for 5 seconds. I need to check this first. RTT object. Okay, this should be the first one. I have set the delay for the, I hope it's the first one, but we can remove the connector here to check the behavior. Okay, it's TT, lane 1, lane 2. Okay, I have a failure. This is double turntable track, lane 2. And then I guess it's moving wrong. Okay, once again. I need to turn this by 260 degrees, and then we need to change the position of this part here. So once back to our turntable, double turntable open in 3D. And we need to change the MU animation path, show at the chip, and this is 270 degrees. And this lane 1, the same. No. Okay, let's have a look. Okay, it's now turns the part. This we can change later on. Okay, method is running until this point. We wait 5 seconds. And then we move it to the right exit. The exit here is L4 in my case. And so I need to double turntable track lane 2. Point, move. L4. And then I need to wait 5 seconds until the part is exit completely, and then I will call this method again. Okay, and this we need to do also for the other lane. And this would be a else block. We can copy most of this. I copy the complete code here. We need to wait until. So the position is here 2 times P. We need to check if we are already on 2 times P. And then we move the stuff to lane 1. And at the end, we go to L3. Okay, let's check this. doesn't turn here. This is not right. Yeah, I forgot here. One tournament here, but it is here the same here. We need to turn to 2 times P. And need to wait. And here we need to turn to 1 P. Between, sorry. This control could be much more difficult. For instance, if you have to wait until both of the lanes are occupied and then turn. Okay, I need to reconnect this source here. And 1. Copy and paste. Most complicated operation in Blend simulation. Okay, now we only need to change the orientation of the part here during the animation on this turntable element. Okay. Open 3D. We need to go here into the 3D attributes, MU animation, and here can set the MU rotation. Animation. Pass. Line. Edit. No idea why it's minus 90 degrees. No, I need to check this. Some automatism here. Yeah. And the same for the other one. 3D, MU animation, animation pass, line, edit. No idea why here is 90 degrees. Okay. So now it's running. Time is almost over. Any questions?
This was a really complex topic compared to some of the others. So Stefan, thank you for doing this live while we're all watching. This screen that you should be seeing now, there's a link to the forums, and that's a screenshot of the forums. So this is the area where the video will be posted. So you definitely want to save that. And then these are the next 3 topics. So there's only 3 more sessions before we take a break for Christmas, New Year's, just take a break for about 4 weeks. So you can see the next topic is conWHIP control. So the registration link will also be in this forum on Friday. Then in November 26th, the random worker behavior, December free driving AGV basics. So those are the next few things. And the image also should be animated for you. It's showing our recommendation to subscribe to the topic. So you click the follow button, and then there's a second click to say that you want to receive notifications for every post. That is because the only thing posted in that area are the new topics. If we do a survey for new topics, and then we also post the recordings. So that is the only thing that's happening in that part of our forums. And that just helps you get the information immediately instead of waiting. Some people receive emails, other emails from Siemens, but this is the fastest and easiest way. So definitely give the forums a follow. And there are some general questions there. So Stefan, if you want to steal the screen back, someone was asking, what did the pi variable stand for? Maybe you can kind of show them in the software.
Oh, pi, it's just 3.14 and so on. It's the variable p, pi. It's just pi. You need for the math in triangles and to calculate the circumference of a circle. This pi. It's a constant.
Good. It looks like that answered the question.
Yes, it's a lot of steps in 3D. It's something sometimes for me also surprising how many steps it needs. But if you learn a little bit about 3D, how to create animation paths and how to set up the appearance of the elements, then you can create almost all in production areas. Also, if you don't have standard elements in Blend Simulation.
Yeah, so I see Carlos is asking, would it be possible to create a dynamic connection to know where the mu, right, MU, needs to go?
Yes, but then you need to have exit controls in the conveyors to avoid the direct movement to the successors. And nevertheless, you need control for the turntable. But in Blend Simulation, for instance, if you have elements, you can use the attribute destination of the MU, and this you can use for select the right exit if you have more than one, and you can have 3 possible exits. And so you can use, for instance, here from the part routing, you can use the destination attribute to set a destination, and then select in the method the right exit and the right turn position.
Okay, so it looks like there's a follow-up question asking if it's better to create an MU to simulate the double turntable than to use the object angle from any object in the plant.
Okay, what kind of MU do you want to create here? You can also use double. If you don't need the turnment, then you can just use 2 different single blocks. If you don't have, it's a matter of abstraction here. If you want to see the movements, and if you have some restrictions, constraints for this element, then maybe it's worth the effort to create this as a double lane turntable. But you can also use just a black box. It goes in and comes out, however. And so it's every time what do you want to see and what your customer want to see, and what's the question you have to answer here. And such double turntables can be bottlenecks in logistics and conveyor systems, and then you need to simulate this as turning element. And object answer, you cannot you need something underneath the MU, like a track here, to turn, or a single station. There are several ways to simulate this.
That's great. And a thumbs up. So we've got another second. We can go probably till 10 after. If you're still thinking of your question, come up with a way to ask it in the next minute. One last slide I did want to share is just about, again, a reminder of where the community forums are, and also that Stefan has a profile in our community forums. He's typically available. You can @mention him. Is the slide showing is the question, because I don't see it. So I'm guessing the answer is no. Let's try that again. Okay, there it goes. So this is, if you click on that link on the screen there with Stefan's name, that will take you to his profile in the community forums. And again, the link that is there is to the virtual user group where the recording will be posted on Friday. So wanted to call that out again, and it does look like another question appeared. So looks like Ivan's asking, it's saying that the method has a lot of complexity. He's asking if there's a manual available to help better understand the method logistics.
There's no manual for this. We upload this this model on Friday, set this model in the forum, and then you can check some word, press F1, and then you get to the help of plan simulation and can check the meaning of the commands here. But it's not so complex here. It's only a few lines. There are only some lines. This is wait until. We wait for a target that's the turntable doesn't move anymore. Then we check the actual position here. Otherwise, we need to wait until the target position is -1. If we're not on the position, we need to change the position. This is target position, and this is just moving the part to the right lane. We wait. Target position again is movement, and then we move the parts to L4. It's not really complicated here. And you can check all the methods or commands just by press F1, and then the help of plan simulation should open, and you get the extended description of each of these commands. Okay, next one. I would like to know about material handling system using forklifts. Okay, I have it already in my list, and there will come a webinar for forklifts also.
But that is the end of our presentation. If you do have other questions, definitely take them to our forums. Hopefully you bookmarked the link that we shared a little bit earlier. And however you heard about the registration, you'll be able to hear about the next session as well. So thank you everyone for coming, and thank you, Stefan, once again for presenting.
Goodbye.
Bye, everyone.